Hello all, welcome back to my data structure series. Today we are going to solve Leetcode problem number 4. Given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of two sorted arrays. The overall runtime complexity should be order of log m plus n. There are examples for you. Here they have merged the array and found out the median, but we will solve this problem differently in time complexity order of log minimum of m comma n, which is very optimal and it satisfies the requirement. It is less than order of log m plus n. So these are my core concepts. Split both the arrays into left half and right half such that left side has equal or plus 1 elements than right. Every element in the left is less than or equal to every element in the right. So if the total number of elements of the array is odd, median will be maximum of left. If it is even, median will be maximum of left plus minimum of right by 2. The important trick is that apply binary search on the smaller array to keep it faster. So these are my core concepts. Only with this I am going to achieve the optimal solution when compared to the problem statement. Look at my first example. Nums of 1 is equal to 1, 3. Nums of 2 is equal to 2. Make always nums 1 smaller. Keep nums 1 smaller is an important design choice because binary search runs on nums 1. Smaller array means fewer steps, so we get guaranteed order of log minimum of m comma n. That is why I am making nums 1 smaller. Nums 1 is equal to 2, nums 2 is becoming 1, 3. Total length is 3, so left side should have 3 plus 1 divided by 2, which is equal to 2 elements. Now cut the arrays. How should the arrays be cut? Nums 1 should have left and right side, num 2 should have left and right side. Split nums 1 at position I, nums 2 at position j. J will be equal to left minus I remaining. So I equal to 1, nums 1 left will be 2. J equal to 1, nums 2 left will be 1. So left side will be 2, 1, right side will be 3. So now check for the condition. Look, maximum of left is less or equal to minimum of right. So median is equal to maximum of left, which is equal to 2. Very simple. So initially it was looking scary, but now it has become simple. So I have another example for you. Here nums 1 is equal to 1, 2. Nums 2 is equal to 3, 4. Cut. Nums 1 becomes 1, 2 on the left, nothing on the right. Nums 2, nothing on the left, 3, 4 on the right. So you have left side and right side now. Check for the condition. Maximum of left is less or equal to minimum of right. So find out the median, which is 2.5. Another example where nums 1 is equal to 1, 3, 8 and nums 2 is equal to 7, 9, 10, 11. Total elements are 7. Left side should have 7 plus 1 divided by 2. That is 4 elements. Cut. So look, left side becomes 1, 3, 7, 8. Right side becomes 9, 10, 11. Check for the condition. Median will be equal to 8. So this is how we are going to solve the problem. So my overall idea is simple. The very important point is we have to cut. So why cut? Trying to simulate the merge sorted array. But really we are not merging the array. Because once you merge the array, the time complexity becomes m plus n. Whereas we are not merging the array, so we are getting a minimal optimal time complexity. So you don't agree? We can prove it here. The time complexity is order of log minimum of m comma n, which is less than order of log m plus n. That is a requirement. Assume m is equal to 2, n is equal to 1000. So what is log of minimum m comma n? Log of 2, which is 1. What is log of m plus n? Log of 1002, which is 1. So this approach is much faster and is still fitting the requirements of the problem. So this is my overall idea. Make sure nums 1 is smaller. Apply binary search to choose a cut position. Compute j. Check whether the partition is valid. Only if the partition is valid, compute the median. Otherwise, move the cut left or right. So this idea you can achieve an efficient and optimal solution. So I have coded in Python as well as in C. My Python code is very simple. I am making nums1 smaller initially, and then I am getting the sizes, required left half size. Following, I am initializing the binary search, I am looping, I am computing the cuts, I am getting the boundary values. You can see the values: max left 1, min right 1, max left 2, min right 2. And then I am checking if my partition is right. This means that all elements on the left is lesser or equal to right. And then I am computing my median. And then if too many elements on the left of nums1, I move cut left, else I am moving cut right. So this is how I code in Python. And then this is the C version of the same logic. Int minimum acts as minus infinity, max acts as plus infinity. I have used a recursive swap which ensures nums1 is smaller. Ternary operators are used for boundary conditions. You can see max left 1, min right 1, max left 2, min right 2. They are all for the largest values on left of nums1, smallest values on right of nums1. Largest values on left of nums2 and smallest values of right of nums2. So these four numbers completely determine whether the cut is correct or not. So these four boundary conditions are very important here. And apply binary search to find partition, whether the partition is the left half contains a correct number of elements when compared to the right, and every element of the left should be less than or equal to every other element on the right. So this is a complete picture of my C code. Any doubts, post it in the comment section. I'll be happy to explain. If you have even more optimized version, please do post it in the comment section. Happy learning. Thank you.